Now finally let's move on to the chemical properties of carbon. Combustion reaction, boom, kaboom, let's start. So this is how a combustion reaction looks like inside the engine of a motorcycle. Trust me, it does. But we won't be able to see it, unfortunately. So chemical properties of carbon compounds. The first one is combustion. Most carbon compounds also release a large amount of heat and light on burning. Why is this hydrocarbon so important to us? Guys, all the fuels that you use for your motor vehicles are nothing but hydrocarbons. So let's see, methane. You remember methane? Natural gas. Compressed natural gas. CNG. So, CH4. Now, what do you require for combustion? What do you require for burning? It is oxygen. So, CH4 plus O2 will give you nothing but. Now, what will happen is this carbon and hydrogen bonds will break. And when they break, they react with oxygen. So, carbon reacts with oxygen to give carbon dioxide. Hydrogen reacts with oxygen to give H2O. And a large amount of heat and light is released. So, therefore, how to balance this reaction? Carbon is 1, carbon is 1. Hydrogen is 4, hydrogen was just 2. So, I multiplied it by 2, making oxygen 2 and 2, 4. So, 2 oxygens on the left hand side. What would you do? Multiply by 2, and there you have it, a complete reaction of combustion. So be it any compound, doesn't even matter. When the question comes, what will be the reaction of when you combust it or burn it or heat it in the presence of oxygen, you will always get the products as CO2 and H2O. Remember that. So CH3, CH2OH, that is nothing but ethyl alcohol, C2H5OH plus O2. What will happen? Nothing. Carbon dioxide and H2O. So CO2 plus H2O plus heat and light. So even you might have seen those flame shots. So that is an indication that even alcohol burns. So carbon dioxide, H2O, and an immense amount of heat and light. To balance this reaction, carbon is 2 on the left hand side and there is only 1 carbon. So multiplied by 2. Hydrogen is 3 plus 2 plus 1, that is 6, and there's only 2, so multiply by 3. So the total amount of oxygen over here on the right hand side becomes 4 and 3, that is 7. And on the right hand side, it is 1 plus 2. So if you have to make it 7, you just multiply the O2 by 3 plus 1, so you'll get it as 7. So you can clearly see now, 1 plus 6, 7. So the reaction is balanced. Oxidizing flame, saturated hydrocarbon. Now all the saturated hydrocarbons containing a single bond will burn with a blue flame. That is why you see your ghar ka gas burning with a blue flame. That is why you will see candles burning with a yellow flame. You will see matchsticks burning with a yellow flame because all unsaturated hydrocarbons, meaning a double or triple bond, have a reducing yellow color flame. So combustion, simple, saturated hydrocarbons, burn it, you'll get a blue flame. So this is a huge saturated hydrocarbon. Similarly, take a unsaturated hydrocarbon, burn it, you'll get a yellow flame. So this is how you understand whether it is a saturated hydrocarbon or unsaturated. But there are even more differences in that. Like for example, saturated hydrocarbon go into a complete combustion, whereas unsaturated hydrocarbon go into an incomplete combustion. So how would you see that? Let's take 2 glass, put saturated and unsaturated hydrocarbons. When you burn, you'll see a blue flame, and over here you'll see a yellow flame. Also, you'll see that this is a clean flame, whereas this has a little bit of black smoke coming out of it. So clean flame, black smoke. What is the residue? Can you see a black residue was found? So no sooty deposit, and there is a sooty deposit. That is why we call it as an incomplete combustion. So this is the difference between a saturated and unsaturated hydrocarbon. You'll see when you burn your gas at home, there is no deposition for years. But when I burn wood, there is a lot of ash left behind. So that is a clear indication of the sooty deposit. Let's move on. What is the reason for incomplete combustion? Very simple. If you keep an air hole open, you'll see that with fully open air hole, a lot of gas goes inside, a lot of oxygen goes inside. So the amount of oxygen required is there. So it will always give a non-sooty flame, meaning there will be no deposition. But when the air hole is closed, if you just adjust the Bunsen burner, you can close the air hole. That means it will not give a clean flame, and there will be sooty deposits. And you can see clearly, you can do that in your lab. As we go on reducing the amount of air going into the burner, the gas in the burner starts burning with a sooty flame. That is, a black smoke will appear at the top. So, why? The bottom of cooking vessels gets blackened. Why? You might have seen this. Brand new vessels, after maybe 6 months, after maybe 10 months, they turn black at the bottom. Why? Because when you keep it on the flame of the gas, they almost cover all the oxygen. And because the oxygen is less, what happens is a sooty black deposit is kept. So the unburned carbon particles get stuck to the bottom of the cooking vessel, resulting in the blackening of bottoms of vessels. Guys, I'll see you in the next module with a lot of interesting stuff. Stay tuned.